we are going to be talking about focusing light. So we're going to discuss sort of how the lens, which is in this diagram here, and the ciliary muscles, these are ciliary muscles, and suspensory ligament, and finally the lens I'll fill in. We're going to be figuring out how these sort of groups of tissues or organs, if you want to call them that, come together to actually focus light. But first of all, before we talk about that, is what is focusing light? And if we go back to this diagram of our arrow, this arrow will have light falling on it from a light bulb or such things, and then it will reflect light back. That light will go everywhere. It's not just going to go in these three straight lines. It will go bang, 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 bang. But we don't mind that light because that light's not going into our eye. We need to focus on the light that's going into our eye. Equally, we could draw loads of lines through here as well, around this area. And they might go in, but I'm only going to draw 3 for the sake of simplicity and ease. So what actually is focusing light? So this light is being reflected and it's going through our eye. And I want you to think of focusing light as recreating a clear image on the retina. And as we go through it more and more, it will become more obvious what I mean by that. But just bear this in mind. So if we talk about what's actually happening here is all the light coming from this single point on the arrow, these 3 beams, which are representing lots of beams, we need to reform them on the retina as a single point. If it doesn't come back together to a single point, then you're going to have blurred vision. And your lens is what does that. Your lens gets light that is moved, so these light rays will tend to move away from each other. They might even be parallel in some diagrams, but your lens then brings them back together at this point. And that's what focusing is. It's bringing light rays that are coming from one point back to one point onto the retina. And it has to be precisely onto the retina. So what about all the other rays of light? So what about all the image from this area? And I'm going to show you. And this is, so for example, here again, for simplification, ignore this green bit. I don't know why that's there. For simplification, I've just done one at the top, one in the middle, a point in the middle, sorry, and a point at the bottom. There will be light rays coming from all of these places in between. So there will be light rays coming from here and here and here and here as well. But I'm just going to show you where 3 points would go and how that actually reforms an image on the retina. So the light rays coming from here, the light rays coming from this point will go to that point over here. The light rays coming from this point here are now going to here after being focused by the lens. They're being refracted by the lens. We are bending light, so this is refraction here and here and here and here and here. They're all refracting the light and bending it so that light comes together at the same point. So if I draw the lawn here, comes together at a single point onto our retina and forms a lovely image. Because now we are, although it's upside down, we do actually see it upside down, which is very odd, I know, but just bear that in mind. Your brain flips it the other way around. You don't particularly need to know that. And you see the light rays coming together all in a lovely clear image here. It's a bit smaller, but it's still, you're getting a nice sort of copy of the light rays coming from this thing falling on your retina. And you only need to understand this for what we're going to talk about today. You don't need to know all these points. You just need to know that those points coming together at a single point is what gives you a nice, clear, crisp image. So, what does outer focus look like? What does blurry vision look like? And this is this. So if we get the focal length or the focal point wrong, so the focal point is the point behind the image, behind the lens, where the light rays come back together beautifully. So here, here, and here. They should actually all be at the same point, but I've drawn this terribly. If we get that point wrong, and that point doesn't fall on the retina, it either falls in front of it, or it can even fall behind it, as we'll see later, you end up getting all the light from this single point getting scattered over this whole area of the retina. and the light from this single point getting scattered from this whole area of the retina, and finally here getting scattered. So our brain no longer knows exactly where that light is coming from in front of us. We're not actually able to pick where the end of an object is, where precisely is the point of this arrow. All we know is it is roughly around here. And the way we perceive that, the way we see it in our brain, in our mind's eye, in what we see as vision, is blurry vision. You get blurred vision and soft edges because your brain isn't entirely sure where the light is precisely coming from, because you're getting this scattering over the retina. The point of all the light is not converging directly on one point. As I said, you don't need to know all this in detail. You'll never be asked a 6 marker on it. I just want you to appreciate what blurred vision is and why we need to try and prevent it. And that's it. So if you understand this diagram roughly, and that's how light works, you're doing well. So if you understand that that's what we're trying to do, if you understand that we're trying to get all the light from this point to converge at this point, you've basically got it.